Hi, my name is Kekling Anangadan. I am from Subgroup 2. So in this study, water washing treatment was employed on kitchen waste, so it integrates multi-product biorefinery process. The goal was to produce biogas, biodiesel, and bacterial cellulose as well as biofertilizer. And while investigating the bacterial cellulose production, it is found that sodium chloride content significantly increased the bacterial cellulose yield. And glycerol from the biodiesel stream enhanced the bacterial cellulose yield while maintaining the quality. The aim of this study is to find an innovative way to effectively utilize kitchen waste. The strategy of the experiment will begin by pre-treatment, adding tap water into the kitchen waste and then separating into two fractions, solid and liquid. Solid will undergo cellular segregation, while liquid will be separated into cook and wastewater. And then the solid will be hydrolyzed with alpha amylase and also aminoglucosidase, and liquid will be separated by filtration. Then the solid will be diluted and then added with peptone, yeast extract, citric acid, disodium phosphate, hydrogen phosphate, and then we prepare the liquid production medium by adding glycerol, NaCl, and separated oil, cook oil. Then we obtain the bacteria, incubate, inoculate it into the liquid production medium, and cultivate it for 15 days. And then we analyze the total solid and volatile solid of the kitchen waste, and after we obtain the bacterial cellulose film, we treat it with sodium hydroxide, wash it thoroughly until it reaches neutral pH, dry, and weigh for yield calculation.
Hi, my name is Pamela Edwin, and I will be presenting on the results in discussion. For results in discussion, it is divided into three parts, which are 3.1, 3.2, and 3.3. For 3.1, it is further subdivided into two parts, which are effects on BC yield and effects on the BC characteristics. In 3.11, effects on BC yield, graph A and C represents the effect of residual NaCl on BC production, while graph B and D represents the effect of cook oil on BC production. It can be found in figure 1A. The BC yield was 2.07 gram per liter at NaCl content of 0.04%, and it was significantly increased as the content was decreased. Furthermore, almost no BC film can be observed when the NaCl content was higher than 0.44%. The rapidest glucose consumption in a group with 0.04% NaCl also suggested the normal metabolism of acetobacter-xylenum for BC production, which can be seen in figure 1C. However, the glucose consumption speed was decreased with increasing NaCl content, indicating the negative effects on the acetobacter-xylenum metabolism. Basically, it can be easily understood that increasing NaCl in the fermentation medium will make cells dehydrated, which will weaken the activity of acetobacter-xylenum and reduce the BC yield consequently. Based on these results, it was implied that the containing salt in the kitchen waste should be properly removed before BC production. According to figure 1b, the increase of cook oil fraction from 0.8% to 8.8% reduced the BC yield. However, the statistical analysis suggested the reduction was not significant. Besides, the residual glucose concentration during fermentation also did not exhibit significant difference, again suggesting the residual cook oil did not significantly affect the acetobacter-xylenum growth. Figure 2 here is the scanning electron microscope image of BC produced from 0.04% and 0.34% NaCl medium. It displayed a significant difference on the microstructure, in which more impact surface was observed on the yielded BC from 0.04% NaCl group, comparing with that of 0.34%, implying a better structure of BC at lower residual NaCl. It was apparent that NaCl hampered cellulose crystallization during the fermentation process. This result also suggested to intensify water washing process so that more NaCl should be removed to improve the quality of BC films.
My name is Clarice, and I'm going to present the part for 3.2 performances of BC production using byproduct of glycerol from biodiesel, which can be seen at figure 3, the replacement of glycerol from biodiesels for BC production, A, the yield of BC, B, the concentration of glycerol and glucose during fermentation at 50 gram per liter. Overall, BC yield from glycerol medium was 34.2% to 44% higher than that of glucose-rich hydrolysate medium when glycerol concentration was 10 gram per liter and 25 gram per liter. However, BC yield in glucose-rich hydrolysate medium was approximately 1.7 times than that of glycerol medium as the concentration was promoted to 50 gram per liter. For figure 4, the obtained BC from glycerol and glucose-rich hydrolysate did not display significant difference on the thermostability according to the thermogravimetry analysis. Although the BC production was greatly reduced at higher glycerol content, the basic characteristic of the obtained BC was specifically intensified greatly comparing with that of glucose-rich hydrolysate. Glucose-rich hydrolysate from starch fraction of Kw and crude glycerol from biodiesel can be well employed as the carbon sources for BC production. 3.3 Concepting a multi-product biorefinery process for valorizing Kw shows at figure 5 the concepted process for valorizing kitchen waste in a multi-product waste. At least 4 bioproducts, including BC, biodiesel, biogas, and biofertilizer, could be obtained via the concepted biorefinery process. Feasible conversion process for each component, depending on their properties, significantly enhance the overall value of Kw. More data should be investigated in depth in further work to support the economic analysis to elucidate the profitability and sustainability of this multi-products biorefinery process for Kw comparing with the various traditional single products mode. To conclude, simple water washing pre-treatment was initialized to concept a valorization process for harvesting bioproducts. Crude glycerol could be a replacement for carbon source to achieve a better BC production and qualities which can enable the biorefinery process to be more integrated and sustainable. Technical feasibilities of valorizing Kw through BC production that integrates multi-products biorefinery provides a new solution to the daily produced Kws in urban area. That's all from us.